Let's start with few problems based on the concepts of wave. Alright, and if you want to understand and go back to the formula, please refer to the summary video where we have all the formulas and concepts listed out in that. Okay, and let's start with few problems based on whatever formulas you have learnt in the chapter. Let's look at the first one. See the first one, a string of mass 2.5 kg is under a tension of 200 Newton. The length of the stretch string is 20 meter. If the transverse jerk is stuck at one end of the string, how long does the disturbance take to reach the other end? So basically what you have a string like, you have a string like this. You are going to have a transverse jerk motion on one end. In the sense, the same thing, we are going to make it like this, one transverse jerk motion at one end of the string. And this is going to move towards the other end. How long does it take to go from here to there? See, when they say how long does it take, it's basically time. If you know velocity and if you know what is the distance, you can pretty much calculate the time. Distance, what is the total distance of the string here? That's 20 meter. So it's given to you. Let's list down what is given. Alright. First, mass 2.5 kg. Then tension 200 Newton. Then what is given? The length of the string is given, which basically is the distance. Let's call it as length. So length is given to be 20 meter. To calculate the velocity, we need mass per unit length, isn't it? Because what is the formula? The formula is V is equal to root of T divided by M. Well, that small letter m what we are looking at, that is mass per unit length. Let's calculate that one. So we have m is equal to mass per unit length. That's 2.5 over 20. You can keep it as it is, or if you want, convert this into decimal. Okay, it's your wish. So many kg per meter. Now if we apply the velocity formula, you have V is equal to root of T divided by M, root of 200 over 2.5 into 20, which if you simplify, you are going to get 40. Alright, so you have 40 meter per second. This is the velocity. Now we need the time taken. Use the formula. See, what is velocity? Velocity is basically displacement by time. Correct? So in this case, we have time is equal to L divided by V, which is 20 over 40. Therefore, T is equal to 0.5 second, or half a second also you can take it. So what we are looking at, a time of 0.5 second, which the time taken by the wave or the jerky motion to travel from one end to the other end. Alright, this is how you need to solve. Remember, these are one type of problems where we are looking at just direct application of formula. Nothing more, nothing less. Okay, now let's start with the next one now. Next one, you have a steel wire has a length of 12 meter and a mass of 2.1 kg. What should be the tension in the wire so that the speed of the transverse wave on the wire equals the speed of the sound in dry air at 20 degrees Celsius, which is 343. Again, the same formula. Whatever the type of problem you did in the previous case, it's the same formula, same logic, no change. But instead of giving in the previous one, they were asking what is the time period, correct, to travel. But in this case, they are asking you what has to be the tension, correct? T value is what they are asking. Again, let's list down what is there, what is given to you. The length of the wire, L is equal to 12 meter. Mass is given by 2.1 kg. And you have the speed of the sound, velocity, V value is equal to 343 meter per second. Alright, then calculate mass per unit length. M is equal to mass per unit length, which is 2.1 divided by 12, which is going to give you 0.175 kg per meter, mass per unit length. Now apply the formula. Again, the formula V is equal to square root of T divided by M, mass per unit length. Remember one thing, writing the formula is very important in the exam because it's more like an insurance for you. Alright, every problem formula carries some mark at least. That's why write down the formula. So V is equal to root of T by M, or V square is equal to T divided by M, or T is equal to V square into M. V value we know, M value we know. If you substitute, T is equal to 343 square into 0.175, which gives a value of 2.04 into 10 to the power of 6 Newton. This becomes the final value for tension. That means the tension in the string, it's a steel string, correct? So the tension has to be more. So the tension in the steel string is given by this particular value. Fair enough? So this is the answer for the given question. Let's move on to the next one now. See, in the next question, what do we have? A bat emits ultrasonic sound of frequency 1000 kilohertz in air. If the sound meets a water surface, what is the wavelength of? Two sub questions, right? The reflected sound, the transmitted sound. Speed of sound in air is 340 and in water is 1486, correct? Now it's a very simple thing. It's a very simple question, because what we know is we are going to use a very simple formula. V is equal to F lambda, because velocity is known, frequency is known, the wavelength is what you are trying to calculate. Okay, so it's an ultrasonic sound. That means sound which you cannot hear because it's above the frequency what human ear can hear. The frequency is given to be 1000 kilohertz, which is 10 to the power of 6 hertz. Fair enough. Now velocity in air is given to be 340 meter per second. Velocity in water is given to be 1486 meter per second. Fair enough? Now for the first case, A, the reflected sound, wavelength of the reflected sound. Now what is the formula? V is equal to F into lambda, or VA is equal to F into lambda A. Remember, whenever there is a change in the medium, there is no change in the frequency. This you have also learnt in last year. Remember, you had a chapter called light. In there also you did the same thing in refraction of light. There is no change in the frequency. There is only change in the wavelength. The same thing is applicable here also, because any wave, if you consider, all the waves behave in the same way. Alright? Irrespective of what we are looking at, either longitudinal or it's a transverse wave. They all follow the same principle. So that means here frequency remains constant, wavelength is going to change. So wavelength here, lambda A is equal to VA divided by the frequency, and velocity is 340 divided by 10 to the power of 6, which gives us value of 3.4 into 10 to the power of minus 4 meter. Whatever we are looking out is the answer. So this is going to be the answer for the first sub question. Alright. Now for the second sub question, for B, what is that? See, the wavelength of the transmitted sound. So for transmitted sound, again, velocity of the water, frequency into lambda of water. Lambda of water is V divided by F, or wavelength of this one. So you are going to have 1486 divided by 10 power 6, which gives us an answer of 1.486 into 10 to the power of minus 3 meter. This is going to be the answer for the second sub question. Okay, so these are the wavelengths of the reflected sound and the transmitted sound. So in the next video, we'll do a couple of more problems based on concepts of sum.